If you are designing a complex embedded system, chances are that you end up splitting system functions across multiple MCUs and PCBs. This results in designers having to use different MCU families that ideally meet the requirements to build a complete system. Different MCU families come with different architectures, peripheral sets, development tools, and software libraries, increasing the learning curve and risk to your development goals. In this video, we will look at how the PIC24F MCUs and dsPIC33 DSCs can simplify the design of complex multi-MCU systems and enable easy migration across these devices. The PIC24F MCUs and dsPIC33 DSCs have a wide range of performance to meet numerous application requirements and cost. The cost-effective PIC24F MCUs are optimized for low-power performance and offer feature sets that are ideal for implementing display and human-machine interface, connectivity, housekeeping, and supervisory functions in a complex system. The PIC24F MCUs simplify the design of your entry-level variants in a platform. On the other side, the high-performance dsPIC33 DSCs have optimized deterministic response and offer an ideal peripheral set for real-time control applications like signal processing, time-critical and computationally intensive functions, motor control, and digital power applications. The functional, safety-ready dsPIC33 DSCs are suited for automotive, industrial, and consumer safety-critical applications and offer robust operations for up to 150 degrees Celsius. The dsPIC33 DSCs enable the designing of your advanced and complex variants in a platform. There are many applications where a PIC24F MCU and a dsPIC33 DSC can be used to design a complete system. For example, in server power supplies, the dsPIC33 DSC can be dedicated for the digital power conversion, while the PIC24 MCU can be a supervisor, implementing connectivity. In washing machines, the dsPIC33 DSC can implement advanced real-time control of a motor, while the PIC24F MCU can implement the user interface and control all valves and the main washing profiles. In an e-bike, the dsPIC33 DSC can manage the motor drive, while the PIC24F MCU can manage the battery and display module. The low-power PIC24F MCUs and the robust dsPIC33 DSCs offer the same or comparable peripherals and have a common development ecosystem comprising of MPLAB-X IDE, XC16 compiler, MPLAB code configurator, programmers and debuggers, and development boards. This common development ecosystem simplifies the scaling of your application across these device families to optimize your design. It also reduces the initial steep learning curve and enables you to develop your applications with faster time to market. The PIC24F MCUs and the dsPIC33 DSCs share common MCC libraries and associated APIs across the devices. These libraries are configurable using MCC, a graphical user interface tool, to simplify migration of your code to different devices in the PIC24F and dsPIC33 families. MCC offers well-documented API functions that abstract the implementation complexities and enable you to reduce the time to market and reuse your code across families with little to no modifications. The common libraries and the associated APIs speed up your development thanks to familiarity. These common libraries also reduce risk by providing a well-tested and supported codebase. We will now demonstrate the ease of migration from a PIC24F MCU to a dsPIC33 DSC using MPLAB code configurator and the associated application libraries. In this demo, we'll create an example that uses the UART module to periodically transmit a message from a PIC24F MCU. We will then show the ease of migrating to a dsPIC33 DSC with almost no changes to the application layer using MCC, which abstracts hardware dependencies and simplifies the porting. To run this example, we'll be using the Explore 1632 development board, a PIC24F J64GU205 general-purpose plug-in module, and the dsPIC33 CK64 MC105 general-purpose PIM. First, let's create a new project for the PIC24F J64GU205 device and launch MPLAB Code Configurator. Add the UART from the Device Resources viewer. We'll use the default configuration of 9600 baud rate, no parity bits, and enable the UART interrupts. Next, configure the GPIO pins for the UART using the Pin Manager. The PIC24F J64GU205 PIM has the RA12 pin as the UART receiver and the RC3 pin as the UART transmit. Now, generate the code by clicking the Generate button. Now, paste the application code in the main function of the project. The application is a simple demo that transmits the counter value once every second. Next, build the application and program the PIC24F MCU. Open a serial terminal and configure as necessary. You can see the messages on the screen as expected, with a count incrementing every second. We will now migrate the same demo application to the dsPIC33 DSC. Let's start by creating a new project for the dsPIC33 CK64 MC105 and then launch MCC. As we did with the PIC24F MCU, add the UART module and set up the UART. Next, configure the GPIO pins. On the dsPIC33 CK64 MC105 PIM, the UART receive and transmit pins are mapped to RB7 and RC3 respectively. Next, generate the code using MCC. Migrate the exact same application code developed for the PIC24F J64GU205 by copying from the PIC24F project into the dsPIC33 project. The MCC generated peripheral and device drivers abstract all the hardware dependencies and offer the same function APIs across the PIC24 and dsPIC33 devices. This feature of MCC drivers and application libraries allow you to easily repurpose the application code developed for the PIC24F MCU and use it in a dsPIC33 project. Now, compile and program the dsPIC33 CK64 MC105 PIM to see the same serial communication output. Sharing the same application libraries and common development ecosystem, the low-power PIC24F MCUs and the robust dsPIC33 DSCs offer a wide range of performance and enable the addressing of different functions in a complete platform design. The PIC24F MCUs and the dsPIC33 DSCs also enable easy migration while repurposing most of your development efforts. To learn more about our PIC24 and dsPIC33, please visit microchip.com/PIC24F-dsPIC33. You can also download the code example shown in this video from our GitHub page linked in the description below. Thanks for watching.